We're going to go over rearranging formulas. And the second one, we're going to go over them when they have powers involved. So in the very first one, just to recap, say we have the letter A and we need to isolate for L. When we isolate for L, L does not have to move on what side of the equation it's on. And when we talk about sides of the equation, we mean on either the left or the right of this equal sign. So if we're isolating for L, the easiest thing to do is to leave L by itself and move the other letter over. In this case, it's a positive E. So when the E becomes moved to the other side, it becomes negative E. So in other words, L is equal to A minus E. With that same idea being said here, let's say we're trying to isolate for V. V is a little more difficult to isolate for. Right now it's on the bottom of the fraction. Okay? And if I just move M over, what's going to end up is I'm going to have 1 over V, which is not what we're looking for. We're trying to get V by itself. So whenever we're trying to isolate for the bottom of a fraction, it's actually best to work this in 2 steps. To actually move the V so we no longer have fractions anymore. Since it's divided by, when I move V over, it becomes multiplied. So on the left side we have D, V is equal to M. We're still trying to isolate for V. So now we move D over, and because it was multiplication here, we then divide. So it becomes V is equal to M over D. Okay. Now here's a more difficult question. This is volume of a sphere, I think, this formula. We're trying to isolate for radius being R. This becomes difficult, A, because we have a fraction, then we have a symbol, and then we have an exponent, 3 things we really have not talked about yet. So we want to isolate for this R variable. The first thing I want to move is this fraction over to the other side. Now, since we already know our fraction rules, I'm going to try to simplify this. If I were to multiply all of these by each other, technically these are fractions over 1. And when multiplying fractions, we multiply all the top by each other and all the bottom by each other. So if that's the case, 4 times pi is 4 pi. And then 4 pi times r cubed is 4 pi r cubed. So nothing changes. We keep them all the same. But on the bottom of the fractions, remember all of these were over 1. 3 times 1 times 1 is just 3. So this might be a little easier for us to look at when we're manipulating. Because now we can see that we need to move the 3 over. And when we move that 3 over, because it's divided by over here, it'll need to multiply on the other side. So we'll be left with 3v is equal to 4 pi r cubed. Now remember, the goal is to get r by itself. We can move 4 by itself and then pi, or we can move them as a pair. Because technically 4 times pi is some constant number. It's probably 12.7, blah, blah, blah. There you go, something around there, okay? So instead of writing a very long decimal that goes on forever, we leave it in pi form so it's easier to manipulate. So because it's a constant value, I'm going to move 4 pi. So I want you to think of 4 pi like it's being multiplied by r cubed. When we move it over, we'll have to divide. So we'll get 3v divided by 4 pi is equal to r cubed. Now this is something we haven't really dealt with. Because this is cubed, the opposite of a power is a root. Okay? So if I have 2 to the power of 2, the opposite of this is a square root. And in a square root, there's technically the number 2 there. So if we have 2 to the power of 3, the opposite of that would be the third root. X to the 4, fourth root. Y to the 26th, 26th root. Okay. Yeah, and then the x would go underneath, yeah. So, because we're trying to move this third or power of 3 to the other side, it's going to have to affect everything over here. Okay? So all of this will have to go under a root, and because it's the value of 3, it'll have to be the third root. So we'll have to find the third root of 3v over 4 pi is equal to r. So essentially it looks like this. I'll try to write it a little cleaner. 3 over 4 pi. It's the same thing. I'm just writing it so it's a little easier to look at. That would be this answer isolated for R.